Hi everybody. Today my topics is Cramer's rule to solve a systems of linear equation containing two or three variables. Using matrix, we can solve a system of linear equations. However, it can be used only when the number of equations equals the number of variables. Let's move ahead. Today, my discussion will be on Cramer's rule, already I mentioned. And this Cramer's rule, which is most often used for system of two equations, two linear equations containing two variables or three equations containing three variables. And this method actually based on the concept of determinants. It is most important points. So here we'll bring two equations. First one and the second one. For these two equations, our first task is to write determinant. In this determinant, it looks 2 by 2 matrix and it has four real numbers. What is those? We can see here four real numbers. Numbers are A1, A2, B1, B2. And these four numbers, if we calculate the value like A1, B2 minus A2, B1, the results will be a number also. Now, I shall write another determinant. It is in terms of x, like dx. This one. This one, how? What is the difference between this and this? It is most important point to learn also. This one formed by replacing the entries in the first column. You see here first column A1, A2. It is replaced by C1, C2. Where from it comes? Right hand side of this equation, these two constant. Then if we go for dy, here this one, here it is formed by replacing the entries in the second column, because see here B1, B2, but here what you did C1, C2. So right hand side of these two equations, these two constant. This is most important point, how to find dx and dy. Now for the solution of x, dx numerator will be dx and denominator will be d. If we find y, same way we have to write this one dy, numerator, and denominator will be d. So we have to memorize this, how to find x and y. Now in next slide we shall see the example. We are bringing two equations. Here our first task is to find the determinant. Now this determinant, I mean inside these four entries, it is nothing but coefficient of this x and y. To find the value, 3 multiplied by 1 minus of minus 12. So it comes 3 plus 12, 15. Here one thing is very important. D is not equal to 0 because our D is 15. So the system has the unique solution. This is also most important to verify this, either if it is 0 or not 0. So once we are happy with that, so we can go for finding dx. The formula already I explained in the last slides. Only I have to put the value of C1, C2, B1, B2 from here. So we put the value and this cross 4 multiplied by 26 minus 26. It will be plus, so result is 13. For finding dy, this part already I explained. Only we are putting here the value of this. So 3, 6, 4, 13. From here it came 3, 6, 4, 13. It is 15. So for the solution of x, we have to use dx by d. This is 30, this is 15. So our x value will be 2. Again for y, dy by d, dy is 15 and d is 15, so it will be 1. So our solutions, we already got it. And solution is x equal to 2, y equal to 1. It's not that hard, it's the easy. Now we will use 3 equations which contains 3 variables. Let's see the equations. This is first equation, this one second equation, then we are getting third equations. So we have 3 equations ready. Now our first task, like previous one, to find the determinant D. And here our matrix is 3 by 3 matrix. We'll see next slides how to calculate this D in the example. Now here also the same conditions. If D is not equal to 0, the system has the unique solution. So we have to satisfy this first, then we'll move ahead. Now we have to find determinant in terms of x. Here also it is formed by replacing the entries in the first column. You see here, first column is A1, A2, A3. So this determinant is formed by replacing the first column by these three constant, which is on the right side of the equation. So D1, D2, D3. In case of D in terms of y, it is formed by replacing entries in the second column, D1, D2, D3. It was before B1, B2, B3. It is the coefficient of y. We are finding D in terms of y. So relations like this. So we have to memorize like this way. So D1, D2, D3 is in the second column, these all entries. For the dz, it's very clear. It will be formed by replacing entries in the third column, D1, D2, D3. Because it was C1, C2, C3 and C1, C2, C3 are the coefficient of Z. We are finding D in terms of Z. So these entries are replaced. So once we get dx, dy, dz as well D, so very easy we can find. So our solution for x will be dx by d. Solution for y will be dy by d. And solution for z will be dz by d. In next slide, we'll see one example of having three variables with three equations. Our first equation, this one. Second, this. Third one, this. So our first task, we already know in the previous slide, to find the determinant. So let's write the determinant. And the value, how it is calculated. To find the value of a determinant. And here also you have to just identify that this is 3 by 3 matrix. Okay, to find the value of this determinant, I mean 3 by 3 this determinant, I shall multiply each entry in any row, I mean in any row or in any column by its cofactor and sum the results. That's what we did here. Any row or any column, we can take the entry. So what you will do, we will take the entries of this row and we will multiply these two, 1 and -2 by its cofactor. 2 cofactor will be this 4. So I wrote here like that. 3 to 6, 4 to 8. So 6, 8. If I take these entries, so this line I have to cancel. So I have to keep this remaining 3, 5, 2, 3. These 4 elements. These 4 entries acts as a cofactor. So this is the thing we have to write 3, 3, 9 and 5 to 10. That's what I wrote. And third one also will be same, -2. This column and this row cancel. So we have to take these 4 elements. So we got the value for this determinant -7. Let's move to write for D in terms of X. And this one already satisfied, D equal to -7, so it is not equal to 0. So we can find now D in terms of X. This 3 by 3 matrix, here already previous slide I mentioned, this line, this column, it is formed by these entries, it is formed by this column by what? By replacing, actually this column is replaced by this, and this column for what? This is the coefficient of X. That's why we are finding D in terms of X. So this way we have to memorize this. That is why it is 10, 1 and 4. Others are as it is. So this way we will expand this, all the entries and cofactor, these entries and cofactors, same row we took, and we got the value -7. For D in terms of Y, what is here? Here is this second column, because this second column for Y, so here this second column, this is this one, it is replaced by these 3 constant. So 10, 1, 4. So same way, 3 by 3 matrix, we have to take horizontal these entries, I mean this row, we have to take this row, all these 3 entries, 2, -10 and 2, as well this is cofactor, we got -14. If we go for D, determinant in terms of Z, this column, third column, is replaced. It means coefficient of Z. This is the third column. This is replaced by this 3 constant. So 10, 1, 4 here. 3 by 3 matrix, taking these rows entries, and each entry is multiplied by cofactors, we get 21. Now for the solution for X, dx by d, -7 by -7, here it was -7, this is -7, so X value is 1. For getting the value of Y, dy by d, dy already we know -14 by -7, so it will be 2. For Z, dz by d, dz already 21, d we know -7, so it will be -3. So we got these 3 equations, 3 variables, x, y, z. We got the value of that, x value, y value and z value. And that's all for today. Thanks for watching.